Okay, hi everyone. We're gonna get started. Thank you all for coming for the first lecture of Intro to Backend Development. If you don't know already, we're part of AppDev, which is a project team at Cornell where we make apps for the Cornell community. So yeah, we're just gonna get started with introductions. So we are going to be your instructors this semester. My name is Lauren. I'm a sophomore graduating 2028 in the College of Engineering. I grew up in Singapore. My favorite food is pasta bolognese, bibimbap, and matcha. And these are some of the hobbies. I like to play tennis, snowboard, I do nails. Sometimes I vlog, and I like to cook as well.
Right. Hi, everyone. My name is Joshua. I'm a junior in College of Engineering studying CS. I'm from Jakarta, Indonesia, so like halfway around the world. My favorite food is this Indonesian food called mie kangkung terasi, which looks like this. It's very delicious. It's spicy as well. If you ever come, you should try it out. And my hobbies include playing tennis, basketball, badminton, some pool. I like to play pool at like Cookhouse, playing piano, Duolingo, and doing some Google reviews. I like reviewing like street food. So, right.
Wait, I just want to see like what our students are. So like, can you raise your hand if you're a freshman? Okay, that's like majority of the people here. What about sophomores? Okay, juniors and seniors. Okay, we have one person. Okay. Um, okay, so we're gonna speed run through some logistics before we get started. You should have already enrolled into this course on the Student Center. If you haven't already, please do so because I'm pretty sure the deadline is very soon. And then you have all probably passed the pretest and filled out the Google form. Um, and yeah, so we're gonna have lectures Mondays and Wednesdays from 7:30 to 8:20 in this very room. So we're usually gonna have one day of the week lectures and the other day a demo day. So today's gonna be a lecture plus a mini demo, and then on Monday it's gonna be like a demo day, and then on Wednesday we're gonna have an optional lecture because since we have fall break on Monday, we had to start later. But yeah, at the end of every class, we're gonna have a Kahoot to record attendance. So if you want your attendance recorded, you have to stay till the end. But if you happen to miss the lectures, we're gonna have the recordings on our YouTube. And we're gonna have a Kahoot leaderboard at the end of every week. Um, so yeah, one of our winners from last year is actually here. Yeah, so he got really cool prizes at the
And
end.
top two winners get a prize at the end of the semester. So you gotta grind the Kahoots, guys.
Yeah, and we have weekly assessments that are released every Monday and are due the following Monday, except this week. You'll have 6 total slip days. And you can only use up to 3 slip days on a single assignment, and then after you use all your slip days, it's -1 penalty per day after slip days run out. Yeah, and then this is like the grading structure, 10% for each assessment, assignment, final project's 30%, weekly surveys are 5%, attendance is 5%, and then to pass, you just need a 70%.
Can go back one. Yeah, and also for the assignments, this is like a preview of what you guys be implementing for the backend. Assignment 1, you guys will be making Reddit, the backend for Reddit. Then you'll be making Venmo. You should probably know those two. And then CMS is like Cornell's like CS like grading system in-house, and we'll be building something like that. And last one is a hackathon, is our hack challenge, where you will like work together with people from the iOS class and Android class to build something. That's why I put a mystery box there, but that will be like your final project.
Yeah.
Kissy face, fancy fun play. I'm trying to kiss your lips for real. Red hearts, that's what I want, yeah. Come give me something I can feel.
Wait, you want an egg? Wait, who wants an egg?
Okay, yeah. So as you can see, we will be throwing eggs during class. If you ever answer a question or participate or win a Kahoot, you'll get an egg. And then a few semesters ago, we gave out like these Lego sets to some of the winners. So those are examples of some of the prizes you can get.
Hey, wait, quick poll. Who has a nut allergy or like a peanut allergy? Does anyone have allergies? Okay. Because some of the eggs have like peanuts in them, so just to make sure. Okay, continue.
Okay, so you're gonna have to you're gonna have to bookmark this textbook because it's gonna be super useful for your assignments. It has a syllabus, all assignment information, everything you need is in the textbook. So make sure you bookmark that. Yeah. And then quick note on academic dishonesty. This is a Cornell academic course, so we follow all of the academic integrity guidelines. So there's zero tolerance to any academic dishonesty, including AI. So if we find out about an AI violation, we will automatically drop you. And talking about the assignments amongst yourselves is fine, but copying code is not. So yeah, just cite what you use if it's not yours. And yeah, you do not want to be on the bad side of our faculty advisor, Walker White. So just be careful. And then these are our office hours. So make sure if you have any questions, if you need help debugging, go to office hours or ask on the ed discussion. And then this is a quick course overview. Today we're going to be going over routes and then databases next week or next week and then so on. And then we're going to introduce the hack challenge, which we will match you up with someone from the iOS course, someone from the Android course, and a design course so that you can make an app together in this hackathon. And at the end, we're potentially going to have a career panel with some app dev alumni from the Backend sub team, so that'd be really cool. So yeah, so let's just begin.
All right, so that's the logistics for today and for the course. So today we're going to be talking about routes. And the first thing I want to talk about is the client and server model. So the client and server model, let's start with the client. So the client is any computer, like a phone, a laptop, a tablet, and it can run code locally, and it interacts with the front end of an application. So what it does is it displays content and it can handle user interaction. That's basically what a client is. And then we have the server. So server is also just a computer. However, it runs backend code, which we'll be writing, that can handle data, and it centralizes access to information and it communicates with clients. So the model is really simple. And this is the way they communicate. So imagine you have this piece of string you enter into your URL box. Let's try and break this down. So here we have HTTP. HTTP stands for Hypertext Transfer Protocol. It is a web protocol. It defines message formatting and this basically standardizes transmission across the web. So like when someone sends information, it's in a particular format, so everyone is like standardized and there's no like mismatches. And this is used everywhere. And quick note, HTTPS is the secure version of this where they actually like they what am I trying the word I'm missing? They encrypt. They encrypt the data along the line. So like usually Google is HTTPS, and along this course, you're mostly going to use HTTP because it takes some setting up to get that secure encryption. So we'll be using HTTP in this class for most of your like local deployments. Yeah, so that's the first part. And then we have this part. This part is a domain name. So the domain is not equals to server, right? The server is a computer. The domain is a name for an IP address. So the domain names need to be translated into an IP address. And you can sort of look at this diagram to see how that will work. So this is my computer, for example. And when I want to like search up Google, I do this. So like where's google.com? That goes to the DNS, which is a domain name server. This DNS, it stores like a table of all the website names along with their IP address. So where's Google? I get Google here, 87.245.200.153. They send me back from the DNS, domain name server sends it back to my computer. Then my computer performs the like lookup. I'm going to look for Google at this address. And then it finds the address and then I can look up Google. So that's how a DNS works. Yeah. In this course later, we'll see when you deploy stuff, you usually get like an IP address and attaching a domain name server. So like usually what you do is you buy a domain name. If you guys heard of like renting or buying a domain name like appdev.com, something like that, you have to buy that, you have to purchase it, and then you have to attach it to the IP address. So you have to like link these and make sure the DNS knows the linkage. But yeah, if you're interested in that, you can ask me after the lecture. And now let's talk a little bit more about the client and server and how they communicate. So clients, whatever they send the server is a request. They're asking for something. And whatever the server sends back to the client, that's a response. They're giving back something in response to whatever the client sent them. So let's look at the request first, this part. So from client to server. The request is initiated by a client, starts from the client, and it's essentially a network call over the internet. And it has three things we're going to talk about. It has a URL to indicate like where's the destination of the request, has methods to indicate what purpose that request is. For example, to like you want to write something, you want to delete something, you want to get something, and it has a body. A body is just additional information from the client. And yeah, we'll talk about this in the next few slides. So first, let's go through the URL. So request URL, also called an endpoint, it indicates where the destination is of your request. And it defines a specific route path. So we'll talk about routes more. That's literally the topic of today's lecture. But you can think of routes as like functions, like different functions do different things. Different routes also do different things. And this is a way to integrate data into the URL. So if you're doing Google, I'll show you an example of this, but you can ask Google, like you want to get something, you can put that in the route. And this makes it so that the information is encoded within the path, and you can also add query parameters. So yeah, let's move on to request methods first. Is the second thing. Methods is how you tell the server what you want. So we have four main archetypes. There are more than this, but these are the four main ones. Create, retrieve, update, and delete. And the acronym is CRUD. Not really a nice acronym, but yeah, CRUD. Create, retrieve, update, delete. Create is obviously you want to make something. Retrieve is getting something from a server. Update is trying to like alter something that's already there. And delete is deletion, removing something. And to give you a bit of an example, like this is what I was talking about just now. This is another way to name CRUD: post, get, put, and delete. So we're going to be using this a lot in the course. So post is usually for information transmission. That's when you want to send something from the client to the server. Get is for retrieval, which is like when you want to, yeah, like retrieve is the R from retrieve. Put is update, essentially like you want to revise something like update. And delete is just deletion. So this is just another name for it. It's exactly the same as this, as CRUD, but usually when we talk about requests, we talk about, oh, I want to make a post request, I want to make a get request, a put request, a delete request, stuff like that. And there are actually a lot more. And we call these, we usually call these APIs, application program information, just like this model, we call it RESTful. RESTful stands for representational state transfer. It's a mouthful, but what this essentially means is that you're transferring state when you are like asking Instagram for like all the posts, you're trying to load your feed. You're giving Instagram your state, and Instagram will send a state back, which is including like all your entire feed, right? So there's many other methods that don't use like REST, but REST is the one that usually represents states and sends them across the web. And the last one, the third one, so URL method and body. So this is an example of a body. So like username is Josh and password is I love noodles123. This is definitely not my real password. And yeah, as you can see, it's sort of like a JSON object. You can have like the key here, the key, and you have the value, similar like a Python dictionary. And it's a standardized format, so similar to this. So it can be JSON like this. It can be other things as well. And it contains information you want to send to the server. So you can have like a username and password. I mean, usually you don't want to send a password in the post request because that's not secure. But you can have like image content. You're going to upload image, and take note that this is not the only piece of data, but it's the most useful because it's usually the main way you send data. So we've looked at URL, methods, and body, and let's get into some example requests. So using the same Google example, this is a get request because I indicated get over there. So this is trying to retrieve something, right? You have the Google domain. This is the name of the, not the IP address. This is the name of which server you're trying to look up. And then here, this is the route, slash blah, blah, blah. That's called a route. And in this case, your route is telling you, I want to search for something, right? And lastly, we have this thing here, which is just a bunch of query parameters. This is like another way you can send information. Remember, you can send information through the route because you're telling it to search. You can send information through the body, which is like a block of like text. You can put our password, your username. A third one is like these query parameters, which we really won't use in this class, but it's just interesting if you ever like use Google and you wonder what those are. You're actually transmitting information and you can have key value pairs in the back of that route. Here's an example of a post request, which is like where you send information. Post, because I indicated there, slash login. This is the route here. This time is for logging in. And this is the body. So you have the same format, like the key value pairs, username and password. And it's in JSON format this time. And just to be clear, JSON needs double quotes. If you do like single quotes, that's a common mistake. I made this mistake many times. Single quotes won't work for JSON. So yeah, they must be double quotes. So this is how you would like log in to an unsecure version of Google because you're just like sending the password and everyone can see it. Any questions so far? Okay. So that's the request and response between the client and server. Now let's look at the response. That was only the request. Now let's look at the response. So the response is triggered by a client request. It's usually in response to a client sending a request. It returns confirmation of the request operation in the form of request codes, like response codes, sorry. So like, I'll show you some examples of response codes after this. And it also sends data in a body. So in a post request, you can send body data to the server, but in response, whatever the server gives you back, you can get information as well in the body. So these are some like familiar like response scopes, hopefully. Like 200 means okay, everything's good. 404, if you guys have heard of this, 404 not found, that's a common one. 500, like that's like internal server error. So like these are like ranges. So like 400 to like 500 to like 400 to 499 is usually like errors related to not found or like not logged in. 500 and above is usually like internal server errors. And this is what you don't want to have in your backend because this means you did something wrong in your backend. This is like the backend people's fault. If it's 404, it might be the front end people's fault. So you can try and say that, oh, it's your fault, not my fault. But this usually is our fault. So you better, if you find that, then you know it's like your backend fault. And here's an example of 404, actually. I put a link here. So I don't know if you can see. Let me zoom in. I can't zoom in. But github.com/this page definitely does not exist. This is an example of a page that does not exist, and you get that 404. It's not found. But in this case, it's a beautiful 404. Like they put like an actual page to represent it, but sometimes you might just get a like web error. So yeah, that's 404. And let's look at some example responses. So remember this query? I was getting something from Google. The SAS code, if everything goes well, 200. Everything's good. Okay. And the body might be whatever I'm looking for. So whatever I'm searching for, they might give me like a count of how many things they gave back. So like they give me 100 things. And the result is sent in like this array. And it might not be like this in real life, but this is an example of how it would look. So you get the status code and you get the information in the body. That's what a sample response looks like for get. For post, it looks something like this. So if I want to log in, and I successfully log in, I get 200. And it might return me something like a success response true, and maybe some other data like what user I am right now, the time or whatever. So yeah, status code and body. If it doesn't go well, then you get something like this, 401. So 401 actually stands for something where you're unauthorized to do something. So when you're not logged in and you try to like check out in your Amazon shopping cart, that's when you might get 401 because you're like not authorized to check out someone's random shopping cart. And you can have like the body see success is false, and you can have the error message in the body. So to put in a summary, we have the client and server, both computers, one is requesting to the server, and then one is returning a response. However, in between, over here we have something like, remember how I said routes were like functions? And we have like Google/login, that's the route. And that will trigger my login function in the backend, which is what we'll make. So we'll trigger this route, the login route, for example. Then a data operation happens where I'll like log in the user in my backend. I'll make sure they're like registered and make sure that they're existing user and then log them in. And then I return a response. So after request, these three things happen. These are like very high level topics, but those three happen. And then we send back a response to the client. And then everyone's happy. Hopefully it's not error like message, but yeah, that's how it goes. Is this clear to everyone? I hope this is clear. Good. Right. So I have a question. If anyone wants to try and answer this, is server the same as a database? I haven't told you what database, like what's the definition of it, but I told you what a server is. So does anyone have a guess? And I have, oh, sure.
I think server is more like a computer.
Mhm.
So if you send like a request, it does some kind of computation and gives back an answer. Database is more like a memory where it's like stores everything that you need, and you may send some kind of response based on an API call.
Sure. Perfect. That's perfect. That's exactly what like the answer wasn't yes or no. The answer was literally what you said. So database is a type of server. It's a computer. Database is a computer that specializes in storing information, right? And the difference between the servers, I mean, they're both servers, so it's technically yes, but it's also technically no because they only specialize in storing data. So like I could have like a list of all the eateries on Eatery here, and then my server is the one that does the searching logic. For example, if I want to like sort based on what's open or like filter them, server does that, grabs the data from here, filters it, and then sends it back to my phone. So perfectly correct. You wanna phone it?
Oh my God. Oh, sorry. Oh my God.
Oh, nice catch. Okay. First egg of the semester. No nut allergies, right? You're good?
Yeah.
Okay, good. Thank God. All right. So yeah, database and server are different. Database is a server that specializes in storing data. And the reason why we separate these, I mean, in this course, it will teach you to have this in here. So your database will actually be in the server. Just because we're kind of lazy and setting this up like two connections is kind of difficult and long. So you'll store your data in the server. But for example, on AppDev, what we do is we have like a cluster of databases and we have a server to do the logic. So we actually separate it in our production for our apps. But in this course, we're going to teach you how to just do it in the server for now, because we're not going to like making a scaled app to like 1,000 users. So all the data will just be stored here for now. So how about Eatery? Let's talk about Eatery. I'm sure most of you know Eatery or at least heard of it. It's essentially like a dining hall app, right? On Cornell, made by AppDev. And I wanted to show this just to give you a sense of what backend in real production looks like. So in this case, the client is the phone. Like my phone is a client. The server is AppDev server. We have a server and we have a database as well. In this case, the domain name, we actually attach it to this domain name, Eatery Blue Backend. So if you actually like root your phone or try and see what requests your phone sends when you're opening Eatery, it actually sends to this URL. And to give you a better sense of what it looks like, what a backend looks like, let's remove this client and replace it with my computer. So now my computer is going to be the client, and I'm going to get information from Eatery's backend. All right. Usually, this is the iOS app made by the iOS team on AppDev. But now let's use my computer, because my computer is also a client. It's a computer. So what I'm going to do is I'm going to go here. So I'm just going to copy this and paste it here. Oh. Yep. So I put the same URL here and I get page not found, 404. Remember 404? The request method is get, and the request URL is this one when I paste it. I want to show this better. There you go. And you can see here, like we're using Django as our framework. You don't have to know this, but it's a framework, essentially something to make it, this is something to make it easier. And you can see they have a list of routes here, example routes, or like routes you might want to use. So right now you see we have no route. This is just the base endpoint, nothing on the side. We're just telling it to check out this website and see what's there, but there's nothing. So let's try and see all the eateries on Eatery. We can use this one. So I'm going to do /Eatery. Hopefully you can see that, /Eatery. And if I press enter, let's see what we get. Oh, there you go. So this is what you hopefully want to see when you have a backend. Everything, all the information there. I can click pretty print here to make it into a nice JSON format. Perfect. So you can see number one, we have Gimme Coffee as like all the all the fields, image URL, location, campus area, all of this in like a dictionary format. If I scroll down, you can see more. You can have like, where is it? Why is this all tags? Louis lunch, which is below Sadler, has burgers, fries, shakes, blah, 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 blah. And you can keep scrolling. It's really, really long. As you can see, it's taking me a while to scroll down, but this is like all the eateries in our Eatery backend. If you want to see the items, like the food items, we have like the route item. Think of it as like a function. I'm just querying the function, the item function. Preprint, and you can see we have house tossed salad, fresh cut fruit, like tuna salad, and all these items in our backend. So this is how, like, this is what the front end people will receive when they query your backend. And they'll just get a list of everything neatly like packaged to the base price, dietary preferences, allergens. And yeah, this is like a live backend. And all your phones, when you open Eatery, they query this backend. And I was actually given permission by our backend lead to show this because we didn't really show this in the previous semester. So hopefully this was interesting. Oh, okay. Go back here. All right, any questions, everybody? If there are none, that's good. Because that means I can everything's yeah.
When you're putting the URL of the items,
Mhm.
are you just making a GET request?
Yes. So yeah, there was a GET request to the items. We'll actually show you guys a better way. Like, how do you make a post request? That's a good question. A post request, you need to enter the body and stuff. How do I do it in my browser, right? My browser usually defaults to sending a GET request, like all your browsers. If you like put that URL, you can also see the backend if you want. Just put that URL down and then /item/eatery. But post request, you need to enter information, and I'll show you that maybe like next lecture, because we use like an app called Postman, which allows you to create bodies and send requests, like which I did from the browser. But usually the browser is only for GET requests because it's just limited. You don't, yeah, it browsers for surfing the web and stuff. So yeah, any other question?
Just like a question, like not like about the lecture, but
Mhm.
like does Cornell have their own like API that you get the information off of, or do you actually like manually enter everything?
Yeah, good question. I don't work on Eatery, but we have this website called Cornell Dining Now. This website has all the dining halls and has all the information here, like lunch menu. You can see this. So what Eatery does is it will do something called scraping, where it'll like as a bot, it will run through this website, grab all the information, grab all these list items, put it into our backend in our database, and then everyone can use our backend. So it's similar, but like our backend packages it more nicely. You see how neat that was just now? Here. I mean, not this, but yeah. So it's like we grab everything and we sort it, we categorize it, we give it like, I mean, all the information is neatly categorized, and it's just neater. And we have more control over it. We can sort it, we can filter it. Yeah, good question.
So then like a human would have to like go over it every day to make sure there's not any mistakes in the bot, right?
A human. Yeah, I mean, if there are errors, we will, but our scrapers are usually built to go through all that itself and handle errors by itself. If, for example, Cornell Dining changes their website, oh my God. If Cornell Dining changes the like how this website is made, like just change the order and stuff, then our scrapers will be messed up. It won't like, because it's hard coded, right? It won't like do it properly, and there might be errors. That's why sometimes Eatery is down, because our backend team is working hard to like reformat the scrapers to scrape this. Yeah. Question.
What happens if I send like a post to like delete request?
That's why we have authentication. So if you are logged in or like delete or update post, there are instances of people trying to hack our backend. Yes, and if they can delete or update, then something might go wrong. But if you like, the reason why it's safe for me to show you that is because I mean it's public. All our projects are open source, by the way, so you can look at all our backends. We have a lot of backends on AppDev. You can see them online, and you can try and get. I mean, get is just public, right? No user information required. But like for example, resell, for example, our app that like sells secondhand items. If you were to log into someone's profile, that would be not good. That won't be good, right? So we have authentication for that. And I'll teach you guys authentication in like the 7th lecture. There's a way to handle that as well, to make sure no one just like has malicious intent allowed into your backend. Any more questions? Good question, guys. I'm loving the questions. Another question?
For Eatery, there's a bot that basically scrapes all the data
Mhm.
from the website. So does that bot then create some kind of database or like an API where you guys put the request to?
Good question. Let me show you this diagram one more time. So this diagram, Where do you think the scraping happens? Where do you think the logic for the bot is? It's here. Server is like your brain. Database, think of this as like an Excel sheet with just rows. No logic happens here. Most of the logic happens here. So here we have a scraper that runs every like 5-10 minutes, maybe every hour or somewhat. So every day it will scrape the website. It will get all the information, put it into our database, so it's just stored there temporarily. And whenever a user, like any one of you guys or my computers now, every time a user requests something like all the eateries, it'll grab it from the database because it's already there, send it back here, format it, sort it, filter it, send it back to the user. That sound good? Yeah, so the scraper is here. It's in the where the logic happens in the server. So that's why server and database are two separate things. Question?
You guys use like Postgres for the database?
Yeah, so app dev, one of the things we do on app dev is we have a lot of different languages. So Eatery is not using Postgres. Uplift, the gym app, that's using Postgres. Our new app is also using Postgres. We're making like a service app. Eatery is using Django, and I'm not sure what they use for the back, like the actual database. We have databases using that use TypeScript, and we have, TypeScript is a language, but we have some that uses like MongoDB. So yeah, we actually try and diversify so everyone, when they hop on different apps to work on them, they get to learn different languages. Yeah.
I think Eatery is MySQL.
MySQL? Okay. Well, you're on Eatery, right? That's good.
And like the backend is Python?
For Eatery?
Yes.
We have like the language, we have like TypeScript, we have Python, we have, I don't know if we have Java. We had a side project that uses Java and MySQL. Wait, Manha, what does Eatery use as a language?
Python.
Python, okay. It uses Python. Python and Django, yeah, it uses Django, so Python. Yeah, great questions.
And our new app is using Golang.
We're using Go, even though I've never used Go.
Yeah.
Okay, let's continue. All right.
Okay, so before we get on to the mini demo,
15 minutes.
we're gonna do like a knowledge check. So first, I'm going to talk about documentation. So this is really important for your assignments. Part of our grading scale like requires documentation. So documentation is super important for you and others who use your code to be able to understand its functionalities. So like usually you would have like a comment above like each function, and reading that you like can automatically like know like what that function is doing like really quickly. For example, get task, that comment returns task with the ID, task ID. Reading that comment, like you can easily tell what that function does. But that being said, avoid commenting too much or when it's like unnecessary. For example, data loaded equals false, and then you comment checks if data has been loaded. That's like very redundant because you can like obviously like you can kind of tell like that it checks if the data has been loaded. For example, like that stop sign, like having another sign that says this is a stop sign is like super redundant. But yeah, so try to avoid that, but it's always better to have more comments than none at all. So like we won't dock off points if you comment like too many comments. Yeah, and then debugging, Josh mentioned this, but you will be using Postman to test your routes, and this is how you're going to be debugging your code. So debugging is a process of removing errors from our code, and Josh will be showing you how to use that shortly. And then we also have virtual environments. So before you start any assignment or project, it's good practice to create an isolated environment called a virtual environment. So basically a virtual environment contains packages of specified versions. So it's useful when you're working on multiple projects. For example, if you're working on Eatery and you're also working on Uplift, they're using completely different versions for each like language, for example, or like tool. For example, one project might require Flask 2.0, and another might require like an older version, Flask 1.0.2. So yeah, that's like the purpose of virtual environments, and it's just like standard practice. And you're gonna have to activate and deactivate the virtual environment every time, but we'll show you how to do that. Yeah, and just a reminder to join the ed discussion by Saturday, and we'll be adding you to the CMS, which is how we grade your work. by the end of the weekend. Yeah. And if you ever have any questions, please like feel free to come up to us after lecture or like go to office hours or like ask on the ed discussion. We're like here to help you, so don't be too stressed about the assignments and things like that.
Yep.
Yeah.
Okay, well done. Nice. Okay. So usually we have like one lecture for lecture like this now, and one lecture and like one session for demo, which is how when we teach you guys the actual code and implementation. But for the first lecture, we have like a mini demo, just going through some terminal commands. So let me like make this bigger. Hopefully this is visible. Okay. So hopefully you guys like opened the terminal or like at least heard about the terminal before. Terminal is essentially this is your CLI, your command line interface. For Mac, it's this. For Windows, it's like you can use PowerShell or you can use like the other one. I forgot the name, but this is going to be a crash course of all the terminal commands. So I'm going to speed run this. This is essentially like your Finder or like your folders. PWD, this command, it stands for print working directory. So you print your working directory, it prints which file you're currently in. So right now I'm in user/Joshua/Dirga/documents Cornell appdev FA25 backend course and lecture 1 mini demo. So that's the path. That's what PWD does. You don't have to memorize this, but these are just useful to know. PW. Next, LS stands for listing your directory. You can see what's inside your directory. So if I go into my files, actually, I can do like open dot. Open dot opens your Finder in that folder. So you can see like when I did ls, which is listing, it has the exact same thing as in what's my folder, like app.py, app2.py, and requirements, right? And then we have cd. cd lets you change your directory, which is to move around folders, like clicking folders. So to get out of this folder, because I'm in like a deep folder, I can do cd dot dot. It moves me out. So you can see here, it moves me out of lecture mini demo 1 and it puts me in the thing before that. So this is how you get out of the folder. So if I do like open dot now, you can see like we're outside of the folder. This was the initial folder. If I want to go back in, I just do cd and I do like lecture 1 dash mini demo like that. Or with a slash, it doesn't matter. And I enter, now I'm inside that folder again. And if I ls, everything is still there. Listing. And then we have up and down arrow. Up and down arrows just cycle through your previous commands. If I press up right now, it's going to put ls there. If I press up again, it's going to do cd lecture 1 mini demo. If I press up again, open dot. If I press up again, see, yeah, you get it. If I press down, I can cycle through them. So I can just cycle through all my past commands. We have Control R and Command R. So Control R is to search commands you've done before. So Control R, this has that like back eye search. So for example, if I want to search PWD, let me just type P. And like see, it searches open, open has a P. If I do W, see PWD, and all I have to do is press enter to print the working directory again. So if you have like long commands that you just forgot up there hidden and you want to rewrite them, you can do this. You have Control C, Command C to quit a process. So if you're running a backend, for example, actually I'm going to do it later. But Control C is to terminate something, to like cut it, to like stop it. I'll show you this later. And one more thing that I really love to do is clearing things. So if I just type clear, I'm gonna wipe everything and clear it. But if I just scroll up, it's over here. So it's just like entering a bunch for me. If I do more stuff like PWD, PW, a shortcut is actually Control L, which I love to do. Control L just wipes it again. It's just like clear. Control L. So I can do like Control L. Gone. Amazing. And then we have I think that's most of the code dot. So if you want to open VS Code, which is the IDE we recommend, which is like your code editor, you can just do code space period, and this will open your VS Code like that. Yeah, and if you don't have it installed, what you can do is you can go here. I believe go here. You can do like what like this. Oh wait, it's Control
P.
Control P. Control Shift P. Control Shift P.
Yeah.
It's Command Shift P, and then you can type shell. And here you can install code command and path. So first time, if you've never done this before, your code dot like this is not going to work. Code dot's not going to do anything until you go to VS Code. You do Command Shift. Oh crap! Command Shift P. You install code command and path like this. So if you haven't done that, you might want to do that because it's just faster and I can open and close stuff really fast. Yeah, so now let's go into the demo. I'm gonna Control L. So let's see how to make a virtual environment. So first, I just use Python 3 -m make a virtual environment, and you name it something like my event. That's it. I make that, and if I go to my Vscode, you can see it's made a folder called my event, and inside you have all these packages. This is an environment. This is like your mini computer inside a computer. In here, to activate it, you can do source.bin/bin/activate. This is just a path in here in your event, bin/activate right here. Yep. So once you enter this, it will. Okay, something else. Where am I?
It's my env. It's
Oh yeah, it's my env. Like that. So you do /my or like the name of your virtual environment /bin/activate. Oh my God. Okay. So let me remove the virtual environment. I was too fancy using like a different name. Okay. Let me just name it event because I have my setting on for event. Okay, so now it should be there. And then I'm just going to do source this. This should activate it. So now it's activated. You see the left part event. I'm inside my virtual environment. And here, if I want to install requirements, so for example, here I have requirements.txt. These are all the requirements I need for my backend. Flask, all these I can explain after class if you're interested. But to install them, I'm going to do pip. Pip is Python's installation package manager. Pip install -r stands for requirements. And you just have your requirements file name, requirements of text. It will install everything. And once it's done, I'm going to Control L. Once it's done, you can run your app. So this is what a simple backend looks like. I can just run Python app.py. That's the thing to start Kahoot. So if that doesn't work, it's because your Mac AirPlay receiver is on. So what you want to do is you go to your settings, turn it off, AirPlay receiver off. And let's try that again. Now it works. So now my backend is up. And if I go to this link, you can see my backend should have hello world there. Nice. Now I have a challenge for you guys to get an egg. I have a pre-prepared backend called app2.py. I'm going to run it. This is in local, the URL in local. The second one, this is URL for whoever's in this network, whoever's in this room connected to Wi-Fi. Type this in right now, see what it says, and whoever wins might get an egg. You can do it on your phone, you can do it on your laptop. But oh, see, those are all your GET requests. You're all clients right now looking at my backend.
Yes. Yes.
Okay, he wins. So that's good. So now to terminate my backend, I want to cut it off. I can do Control C. I can do Control C, and that terminates it. Control L to remove everything. So that guy won because the backend was actually, if I go here, reload that. First one to stand up and raise both hands get an egg. So that's what my backend said in the message. And that's an example of how my laptop was a server and you all were the clients. That was the first like client-server interaction we had. And yeah, so the first URL, the first link you have here is the local. So on your computer only. That's what the name of the URL is. And then the second one is for your network. So everyone using the corner Wi-Fi, guy sitting beside you in the library, he can access your backend if I'm hosting it right now. That's how that guy got it. He types really fast actually. But okay, stop accessing my backend. Next is
Wait,
okay.
does anyone need a like refresher on the commands? Like we went pretty fast.
Yep.
Does anyone have the commands like noted down? Okay.
I think we'll post it on Ed discussion because we went through it really fast. But we don't have a lot of time, so let's do the Kahoot. Or let me run through this really fast. Sorry. Let me run through the code really fast. So Flask is the package we use to make our backend. Python's the language. Flask is the package, or like this is the framework we use to have everything. So we instantiate app is a Flask thing, Flask object, and this name is just a shortcut. And then here's our first route, a decorator at app.route. So app was the thing we built here, at app.route / this is our base endpoint. the one without any route, nothing. And then here I have the function that the route will call. So when I hit my backend, I hit this base endpoint, which that guy did. And then I get here, it will run my function hello, and it will return hello world. That's why you saw hello world. And then app2.py, I just changed that to the message. First one to stand up, raise both hands, gets an egg. And then to run it, oh my God, to run it, so if name is equal main, this is just to make sure like you're running the app, not importing app. If you import the app, it won't run. That's just what this line does. When I'm running it with Python app.py, it will run. It runs it on host 000. This is the base. Port 5000. We usually use 5000 or 8000 for ports. In this class, we use 5000. And debug is true. So you can see all the messages and all your guys' queries now. That's the first backend. Hopefully that was interesting. And let's do the Kahoot